How's it going, everyone? Welcome. Elder Gonzalez here. So, let's take a look now at the book, the second book of You Don't Know GS series. To explore about is the scope and closure, one of the most pervasive topic in JavaScript. So we can or I can describe it, then you, if you want to, I can describe is the story telling of why do we even care about the scope, and then answer a couple of questions. How now a JavaScript knows which variables can we have access to a particular statement, and how it handles is variables with the same name. So to answer the first questions, we went through look at the compilations, and so first we look at to understand that the variables, functions, and block, when the author defines them before this code is executed, that evaluation happens is at this compile and parse time. We also look at that from a particular exercise, but it turns out that this relationship is determined, or the relationship of the scope, which determine is how these functions and variables and blocks they relate each other. This structure called scope is determined. I would like to see if that is true, but I do think it is. I do think it is. Because the code decision of where to place variables and blocks with respect to each other are analyzed and according to this exactly. The place where you put these variables and functions and blocks with respect to each others are analyzed by the rules of a scope, or in other words, is the relationship is determined by the rule of a scope, and this happens is before the code is executed. So if we ask to Claude, just to be crystal clear about this, hey Claude, it is safe to say that the relationship between block, variables, and functions are analyzed by a set of rules, aka scope, which in JavaScript is determined before the code is executed. The Lexical Scope and so on and so forth. So the two-phase process, and creation phase and the execution phase. So this is the reason why I'm describing is this, to create this story that reflect is what we can observe from the engine, and because now functions act as a variable, or because functions are first class citizens, aka they act as a value, and you can now hail inside these functions variables. So the scope structure, since it's determined before compile time, no matter where you call this function, it will be is so no matter whatever you call these functions, the scope structure won't be affected by runtime conditions, aka no matter where you call these functions, because JavaScript is two phases. It has the compilation and the execution. Now, because the relationship between the variables, functions, and blocks are determined, are analyzed by the scope rule and determine this scope structure. You can think of this like an object or like a record. Okay. Uh, this structure, no matter when you call your functions, because your functions can are now values in JavaScript. So no matter where you call these functions, this scope structure won't be altered by runtime conditions. So in order to understand that, we look at, well, uh, why we think that JavaScript, which is in essence is not, we don't think it is. So we look at how now a JavaScript behave, which is as a scripted language, it is an interpreted language, but also we look at the compile language, which is the process in which now a source of text can be transforming into instructions that the computer can understand. So the process are different, but the end goal is the same, whether it's interpreted, which is line by line, or compile, which is analyzing the entire project or files, and then generate is a binary code that can be run in any platform that that code was executed, all right, or that the target in which that code was compiled to that particular target platform. Okay, so whether it's iOS or Windows Phone or Mac, or iPhone, or Android, or any of the Linux variants, so for example Ubuntu, Red Hat, so on and so forth. And with that, now, in order to understand how a compile language in classical compiler theory works, it is made of three phases. So you have now the process of tokenization or lexing, which convert all of these different tokens from the human readable language or code into tokens that are meaningful for the language, JavaScript, C++, Java, you name it. And when that happens, the subtle between token and lexing is subtle, because the tokenizer is up to decide if that particular token is part of another token or if a different token. It also make a decision there. So now that convert the source of text into meaningful token, the next phase is the parsing, which is creating now an abstract syntax tree from that strings of token. And once the compiler creates that, it's going to, at the third phase, generate a code, or code generation. So this is something that can be different according to language and platform, but this is now classical compiler theory. So the observable behavior that we can look at JavaScript is that it behaves like two phases. Why is that? Well, because the way how it analyzes syntax errors, early errors, and also is the hosting. In other words, the way how we define the variables inside our functions or block, and because of that, we also look at something that is quite relevant, at least for the theory and also in practice, of what is the process of assigning a variable here. Whether it is this assignment is a target assignment or it is a source of assignment. All right. So it's pretty straightforward when you know what is the source, what is the target of assignment. Okay. And the other is the source of the assignment. So, but again, we look at this is just to show that the lexical scope, which determines the relationship between the block, functions, and variables, this happens is before the code is executed. And a good example of that was with hosting. So this process doesn't create anything. In fact, this process is now created at runtime. And in order to illustrate now how you can, in order to illustrate is this lexical scope, there are some couple metaphors, all right? So for example is illustrate that how the assignment of these variables are determined and in which scope they are determined, variables like marble and scope like buckets, all right? And the scope variables as marble and functions block in global scopes as these buckets, and the bubble at which now what is the range, what is the scope of these particular variables or identifiers, and then how the process of identify this variable name or identifier to which scope this is happening now. This is like a conversation that happened between the compiler and the scope manager, and the other is the assignment of that value to this identifier, which happening is at execution. The engine and the the engine and the scope manager. So we are looking at this illustration because now when it comes to modify the scope, or some gotchas here, we can do that, all right? I wouldn't suggest you to do that because you're gonna mess up with the scope. But it's important at least to understand that how can we mess with that, right? So for example, by defining is eval inside of those blocks. So in order to now look and understand, and in order to understand this question that we asked previously, hey, so despite all of that, how JavaScript know that this at this particular statement, this is the variable that can have access to? And this is achieved by something called a scope change. So anytime that you define as an author a function, a block, or a variable inside of this, or even in the global scope, what happens is you are going to define all of these variables and the relationship of this scope, or the nested structure of this scope, are gonna be determined is via the scope change, which is, you can think of this record that it has a pointer to the outer environment record, right? Which is something that is the technical definitions of that. So anytime that you create now or you define a functions, a block, and also the global scope, each one of them has created at runtime is this environment record, right? So this variable record, that if you have nested structures, so each one of those environment record has a pointer to the outer enclosing scope. And this is how it now resolve its variables behind the scenes. So there is also another concept here, like shadowing, okay, that it say, hey, I don't want to yeah, that is shadowing, okay, and that is if the variable names have the same name at different levels of the scope change, shadowing occurs. In other words, is that that variable will be overridden by the first encounters of that. So this is just to illustrate that, all right, briefly, and now we can understand what these scope chains truly are, and what it's doing, how it works, and what is shadowing, okay, and how you can untrick this shadowing with global shadowing. I do find that this might be quite be relevant for this might be quite relevant for all code bases. There is a lot of old code bases out there when you don't need even to use any transpilation or any build step. So, but in any case, here we are, right? So, so yeah, this is on tricking or on shadowing the global trick. And there's some couple things here, like hopping is not accessing. All right, you can say, hey, I hold that variable here, and this is tricky. So does this another object technique disprove my claim that a special parameter is completely inaccessible? From inside keep looking, no, the claim is still correct. You can still have access to, in this case, from keep looking to the special, because a special is copying the value of the parameter variable into another container. So a property of the same name. And of course, if you put a value in another container, shadowing no longer applies unless another was shadowed too. That doesn't mean we are accessing the parameter special here. We're just accessing it as copy of the value at that moment by way of another container object property. We cannot reassign blue special parameters to a different value from the keep looking here. Especially, you can assign any other variables here from this variable here, from the parameter special here. This is just talking about that. Some couple example here. Another, but if you may be about to raise, what if you use object or array as value instead of numbers, etc.? Will us have having reference to object instead of copy of primitive value fix the inaccessibility? No, mutating the content of the object via reference copying is not the same thing as lexically accessible. And the subtle hint of this, because you can say that this illegal shadowing or tricking shadowing is, hey, now I can is try to fix this, or I can now is create a copy of this value and then pass down to the variable. This is so copy is not the same as lexically available. And we still can reassign the blue special. All of this is just talking from the lexical scope, not from the assignment here. And some of this illegal shadowing. So for example, is, hey, what if I now, um, if I have a variable with the same name, so if I have a function that contains two names with the same name, if I have a function that contains two variables with the same name, one of them is var and the other is let inside of a block, so shadowing will occur. Okay, so lexically you can have access to this. However, if you now put now a var inside of a block and previously a let defined here, so the let special, the let and the var, because the way how this syntax work, it's a, all right, the var reference here, it say this is a syntax error. So this illegal shadowing cannot happen here, because var declaration is function y, which means is here, function y. It's function y. The syntax error description in this case indicate the special has already been defined, but that error message is a little misleading. No such error happens in something, as shadowing generally just fine. The real reason is raised as a syntax error is because the var is basically trying to cross, is because variable is basically trying to cross the boundary or hop over the let declaration of the same name, which is not allowed. The boundary crossing prohibition effectively stop at when you function boundaried, stop at each function boundaries. So this variant raise no exception, because if it finds now a function, right? So here you can now is, okay, let me see if this is true. And now it say, hey, syntax error, identifier special has been declared. Because this var is trying to hop over the let variable, and this is why it throw now a syntax error. You might wonder, why in the F will I find this kind of edge cases? Again, because if you're going to work with this code, you might counter yourself even in libraries, perhaps not that much in libraries, but at least some code bases that you get starting into this industry, you're going to find a lot of legacy code. And at least to understand what is the source of this, where this come from, and it's all about to answer these questions, is to say, hey, how now variables with the same names are resolved at that particular statement. For example, is here. So because now this let special has been declared, and variables are now function y, this is trying to hop over, which now throw a syntax error. So this can be mitigated, okay? This illegal shadowing can be mitigated by wrapping is that inside of a function. And then we look now at the function name scope and the arrow functions. So let's get into this, all right? So function name scope, as you have seen by now, a function declaration looks like this. Pretty straightforward. And any time that we as author define that as question, all right, Well, a new environment record at runtime is being created. Don't take my word for granted. Don't take my word for granted. Take a look now at the ECMAScript uh, to solve that for sure, right? So, for example, is the executable code and execution context. So, for example, as you can see, is this, right? So, an environment record is an specification type used to define the association of identifier, a name, to specific variables and functions based upon lexical nested structure or ECMAScript code. It's just a fancy way to say, hey, this identifier belongs to a variable or a function, and what is the relationship among them, right? Are they nested or are they at the top, all right? And usually an environment record is associated with this specific syntax, which is functions declarations, a block statement, or a catch clause of try statement. So each time such code is evaluated, a new environment record, again, each time a source such code is evaluated, a new environment record is created to record the identifier bindings that are created by the code. The question is, this code is evaluated, it means is executed. Each time such code is evaluated, a new environment record is created to record the identifier bindings that are being created by that code. But this is interesting. I do think that this is each time such code is evaluated. So each time that the function declaration is evaluated, here, this functions declaration, anytime the functions declaration is evaluated, all right. Each time the functions declaration is evaluated, a new environment record is created. When I would like to ask, when the ECMAScript refers to this, the creation, the code, the phrase code is evaluated, it means at runtime or before it. Refers to runtime when the code is actually executed. Oh, okay. So when they mean evaluating and executing, isn't that? So environment record created when outer execute this. Okay. It makes a lot of sense. So this new environment record, which is like a hash table or like a spreadsheet, is created. That is going to associate is the identifiers to specific variables function. Okay, it makes a lot of sense. Good. Now, so yeah, so if you have seen by now, functions declarations looks like this. And then discussed in chapter 1 and chapter 2, a function declaration will create an identifier in the enclosure scope. In this case, the global scope, name as questions. What about this program? This program is also going to create now that, but instead what happened is it's going to be now evaluated is at runtime. This declaration happens happens at compile or parse time, and this evaluation happen is at runtime. The same is true for the variable as question here. So this is being created, but since it is a function expression, so a function defined used as a value or standalone, the function itself would not hoist. You see in chapter 5. One major difference between function declaration and function expressions is what happens to the name identifier of the function. Consider a name function expression like this. So one of the major difference between function declaration and expression is what happened to the name identifier of the function. Okay. Okay, what happened to the name identifier of the function between a function declaration and a function expression here? We know that the ask question ends up in the outer scope, so we can have access to. But what about the of teacher identifier? We can now referencing this inside of the function. Exactly. But what we cannot do is to override its behaviors. Okay. So what about when a function expression has no name identifier? The name function expression is now binding to the variable itself. So a function expression with a name identifier is reference to a name function expression, but one without the name identifier. Let me give me a second here. Okay. Give me a second. Again, everything is possible. Everything is possible. So yeah, here we are. Right. Arrow functions. ES6 added an additional function expression formed to the language called arrow functions. The arrow function doesn't require the word functions to define it. Also, the parenthesis around the parameter list is optional in some simple cases. So okay, why do we even care about the arrow function? Because we look at the scope change, how this actually works, and this concept known as shadowing that answered the question, hey, how now JavaScript know that two variables with the same names are resolved, how it handles that via shadowing, via the how you can how now JavaScript handles before the code is executed at these variable names or these identifiers, okay, and how you can now is shadowing this to define several named variables that are not going to be accessible before the code is executed, aka lexically, to upper variables in there. You can access via cloning that object, that value, but not lexically. So and also we look at the function and why is relevant here, again because it's answered the same question. Shadowing is for variables or any identifiers, and when we talk identifiers like function expressions and also with arrow functions, we looked at one of the most important thing here. The difference between the function expression and the different is how the name is how the names are resolved, right? And how you can now referencing its function expression to itself and not mutated. And now the arrow function. So EXIS added an additional function expression from the language called arrow function. The arrow function doesn't require the word functions to define it. Also, the parentheses around the parameter list is optional in some simple cases like this. This is just describing this. The attractiveness of arrow functions is often sold as shorter syntax, and thus they claim to equate to objectively more readable code. This claim is dubious at best, and I believe outright misguided. We'll dig into the readability of various functions for in Appendix A. So arrow functions are lexically anonymous, aka they don't have any name before the code is compiled. So they don't have any related identifier that reference that function. So they are lexically anonymous. So the assignment to the ask question here, create an infer name of ask questions. But that's not the same thing as being non-anonymous. Exactly. So arrow functions are lexically anonymous, and when you assign this to a variable as a function expressions, they're going to infer the name from that variable. And arrow functions are different ways to define this. So whether it is this, we're just returning something, or whether it is this, where you are getting a parameter and then returning you is this uppercase, or whether you are receiving is several parameters and then you return now an object, or you're receiving is now a collection of arguments using the res operator in functions, and then you want to is get the last element here, or yeah, get the last number of this collection and retrieve this value here. The real reason I bring up arrow function is because of the common but incorrect claim that arrow functions somehow behave different with respect to lexical scope from the standard function. That's incorrect. The real reason I bring arrow function is because the common but incorrect claim that arrow functions somehow behave differently with respect to the lexical scope from a standard function. That's incorrect. Other than being anonymous and having no declarative form, no lexical name, where the name are inferred in the assignment, arrow function have the same lexical scope rule as functions declaration. An arrow function with or without its body still create a separate inner nested bucket of scope. Variables declaration inside of it. This particular appendix, when we explore about this, right? Especially talking about is this implied scope, which is part of the arrow function. Okay, so it is interesting because let me read about this. But I do know what is the intent of this, which is, hey, let's going to talk about that there are certain places in our functions that create scope, that are implied scope. So for example, the parameter scope and then the function name scope. Exactly, in the parameter scope and the function name scope, using now as an arrow function. And the other is anonymous versus name functions. As we discussed in chapter 3, we express either a name or an anonymous form, and it is vast more common to use the anonymous form, but that is a good idea. As you contemplate naming your function, consider name inference is incomplete. Lexical names allow self-reference. Names are useful descriptors, and arrow functions has no lexical names, and immediately invoked function expression also need names. Explicit or infer names. Missing names. Who am I? Broken and also broken. And name are descriptors here. And arrow functions. And immediately invoke function expression. Do this instead. I name if store student here to immediately invoke this. Okay. And return now this. IIFE are typically defined by placing this around the function expression. Exactly. As show, this is showing those previous snippets, but that's not only the way defined and immediately invoke function expression. Technically, the only reason we're using that first round is just so the function keyword is in a position to qualify as the function's declaration to the JavaScript parser, but other are syntax form way to avoid being parsed as a declaration. This and several other unary operators can be placed in front of a function to turn into an expression. The final call is valid, which makes it an immediately invoked function expression. I actually kind of like using void unary operators when defining a standalone immediately function expression. Holy hell. So you can not only here And again, this is getting into the weeds, and I do not know. Okay. Into this, when you say, hey, I'm going to return now this function that say, hey, when you call this, return now this function's reference to student records, and the student records. Effectively creating now is a close over student records functions get student definition. And if I say get student, I'm gonna get that reference as it is, which is here. So all of this I'm saying is that, hey, let me now define these functions here just to organize the code a little bit better, and then return you this value, return you this reference here. So by doing is this, you are saying, hey, let me now inside of this function create now closures, okay? Create now variables that can keep track of every time that I create a new instance of. But all of this is quite okay. But all of this is just to answer that particular question, and that is how JavaScript now knows which variables can have access at that particular statement, and this is via the lexical scope, which are determined before the code is executed. And the way how do we know that is by using hostable examples. Hostable examples like this. Say function, say something, all right? And then you define here, you say, hey, so say something, all right? And here you define is this as salute, right? Say hello, and no, and then it's gonna throw a syntax error, and then you say okay. I do want is to now define here, define is this salute, all right, or might be here to say, hey, let salute be equal to the hola, all right. And you can also say, hey, let salute, but instead of a salute you say avar. And we also see what happened when you use this without that. You say, hey, oh my god, hello, how do you say hello in Portuguese? Como vai? Como vai? I think it is, right? And then you define this salute here, right? And then you rename that, and you might wonder, is that no? All right, and you might wonder, is like, well, what will be now the salute at that moment? So what will be the salute at this moment? So because this now is gonna throw a reference error. Let me see if that, I don't think so. The reference are now hosted. That's a good question. So the reference are now hosted. Say something. It's gonna throw in a reference error here, because the way how now this variables we have access to this particular block scope, aka this, let's salute, it is hosted, but their values is not initialized. Therefore, you don't have any reference to that. So that's why it throws this particular error. So if we now say something like this without this, so the value here will be now is say something, okay, it is say something here, it is now como vai, right? This is an observable behavior and how now as hosting, all right, and how this is something that happens before the code is even executed. So a good example of this was exactly like this, all right. And when you call that say something, it throws you now a reference error, right? So all of this is just to now answer that particular question. How now JavaScript knows at which statement, so how now JavaScript knows that a particular statement, how JavaScript know which variable can have access at a particular statement, okay? At a particular statement. And the other is, well, how now JavaScript resolve variables with the same name, okay? How it handles that? Well, it does that via the lexical scope, as we discussed here. And because any time that we now use a function, a block, or a var, or a variable in its index form, whether it's var, let, or const, the way how they relate each other is analyzed, or the way how they are related each other are analyzed by scope rules, which is, well, defined or analyzed before the code is executed. And if you have now variables, nested variables that overlaps, if you have nested variables with the same names, this is when shadowing occur. All right. In other words, a way of how now you are preventing or somehow is determining is which variables, which identifier it needs to go with. But again, at lexical, at the compile time, and also because with functions definitions and with function expression, one of the main difference is that how can we access to this identifier, okay? And also is the arrow functions that doesn't have any lexical identifier, all right? We look at other places that JavaScript defines scope. Holy French toast. And that is whether it's parameter or function name scope. And the parameter is quite mind bending. And the parameter is quite mind bending because you can also is creating is closure inside of this. So in other words, never shadow parameter with local variables, as you can see here. Never shadow parameters with local variables. And the other is avoid using a default parameter function that close over any of the parameters here. Exactly. And when it comes to determining is if we use an anonymous function or a name function, remember that arrow function name inference is incomplete. Lexical names allow self-reference, and names are useful descriptors especially when you need to define some chains of computations to describe what's going on. uh, Arrow function has no lexical name and immediately invokes expressions, uh, needs name here. That is interesting, and that'll be all for this video. But the question, but there is another question here. So now that we look at this, uh, now that we look at this particular scope that happen is in variables and in block, and also inside of the parameters, uh, exactly, and also inside of the parameters. hmm and also inside of the parameters. Interesting. And the function name scope, or the function expression name scope, right? uh, we also going to look is another scope, which is the global, and we're gonna leave that as it is. So take care. Bye bye.